AI just crossed a new threshold. Models are no longer only getting smarter, they're getting more deployable, more multimodal, and more dangerous as agents. On one side, open systems from Google, DeepMind, and DeepSeek are pushing real serving efficiency and frontier-level capability. On the other, Anthropic-powered tool agents are proving they can quietly turn security theory into working covert channels. What connects all three is the same story. The next bottleneck isn't raw benchmark score, it's how models reason, coordinate, and operate in the real world. Let's explore the first paper. DSpark Confidence Schedules Speculative Decoding with Semi-Autoregressive Generation. DSpark, from DeepSeek AI and Peking University, is a speculative decoding framework that combines a semi-autoregressive drafter with confidence scheduled verification to solve two production bottlenecks at once: suffix decay in parallel draft generation and wasted verification capacity under high concurrency. Instead of relying on a fully independent parallel block like dflash or a fully sequential drafter like Eagle 3, DSpark keeps a heavy parallel backbone and adds a lightweight sequential Markov or RNN head to inject local token dependence while preserving single-pass draft latency. It then trains a confidence head to estimate prefix survival probabilities and calibrates those scores with sequential temperature scaling so they can drive a hardware-aware prefix scheduler that maximizes expected throughput using real engine load profiles. On offline benchmarks across Quinn 3, 4B, 8B, 14B, and Gemma 4, 1, 2B, evaluated on GSM, 8K, Math 500, AIM 25, MBPP, Human Evil, Live Code Bench, MT Bench, Alpaca, and Arena Hard, DSpark raises accepted length over Eagle 3 by 30.9%, 26.7%, and 30% on the 3-Quan3 scales, and over dflash by 16.3%, 18.4%, and 18.3%. In DeepSeek, V4 production traffic, compared with the MTP1 baseline, DSpark improves per user generation speed by 60%, 85% on V4, Flash, and 57%, 78% on V4 Pro at matched throughput, while under strict SLAs, it preserves usable capacity where the baseline collapses, shifting the serving Pareto frontier. Let's explore the second paper, Gemma 4 Technical Report. Google DeepMind's Gemma team presents Gemma 4, an open-weight, natively multimodal model family spanning dense and mixture of experts variants from 2, 3B to 31B parameters, plus a 26B MoE with 3, 8B active parameters. The report's main novelty is a unified multimodal design that combines stronger vision and audio encoders with a 12B encoder-free model that ingests raw 40 milliseconds audio chunks and image patches directly into the language. Backbone. Gemma 4 also adds a thinking mode for explicit reasoning traces, speculative decoding via an autoregressive multi-token prediction drafter, quantization-aware training for low memory deployment, and long context optimizations including a 5.1 local-to-global attention pattern and KV cache reuse that cuts global cache footprint by up to 37.5%. On evaluation, Gemma 431B reaches 85.2 on MMLU Pro, 89.2 on AIM 2026 without tools, 80 on Live Code Bench V6, and 2,150 ELO on Codeforces, while also leading the dense open category on Chatbot Arena with 1,451 ELO. The 12B model shows competitive multimodal gains without separate encoders, and the audio stack achieves a 78% reduction in encoder footprint from 390 megabytes to 87 megabytes, alongside relative improvements of 12% and 10% on Covo ST translation and 17% and 12% on Fleur's ASR for E2B and E4B. Across long context tasks, Gemma 4 scales to 128K and even to 256K token evaluations, with ruler accuracy of 96.4 at 128K for 31B and 89.8 for 26B, A4B, demonstrating that Google DeepMind has pushed an efficient open multimodal system into frontier-adjacent territory. Let's explore the third paper. Tool use enables undetectable steganography in multi-agent LLM systems. This paper from Oxford University and the UK's Artificial Intelligence Security Institute using Anthropic's Claude Opus 4.6 and Claude Code shows that tool using LLM agents can operationalize covert channels rather than merely describe them. Across implementation runs, the agent successfully built undetectable or otherwise functional text stegosystems from the Zamir 2024 scheme from Schroeder DeWitt et al. 2023, and even by discovering details through web search. When the required submodel was absent, the agent added one itself, and when embedded inside an existing multi-agent codebase, an Opus 4.6 monitor could not detect that steganography had been implemented. The paper reframes the problem as a shelling point coordination game and defines coordination indices for algorithm choice, hyperparameters, and complete coordination in a 2 times 2 times 2 factorial over undetectability, shared key versus public key framing, and common knowledge framing. Stronger models showed high algorithmic and hyperparameter agreement, but complete coordination remained near zero in most settings, with non-zero complete coordination appearing mainly in easier, detectable scheme conditions. The main conclusion is that frontier agent steganography is now limited less by cryptographic sophistication than by coordination on exact decoding relevant parameters, making tool monitoring and information flow controls the primary defenses. That's a wrap on today's AI paper highlights. Thanks for watching.